Hi, this is Bob, K0NR. We're going to talk about improving your HT antenna. This is aimed at beginners, so we'll try and keep it simple. Some basic things you can do to improve the signal from your handheld radio, and without doing a bunch of construction projects, simple things you can do. The handheld radio, we call it an HT, handheld transceiver, handy talkie, whatever. It's a handy thing to have. It's a good place to start with ham radio. It's affordable and compact. It has everything ready to go with antenna, battery in the palm of your hand. Typically, these things are going to cover 2 meters and 70 centimeters, maybe some other bands. Typically low power, maybe 5 watts. And we're going to talk about antennas because the 3 best ways to improve your HT signal is antenna, antenna, antenna. Before we jump in too deep, let's talk a little bit about some basic antenna theory that will help us. When you passed your technician license, you probably learned about the half-wave dipole. It's a fundamental antenna that we use for a lot of different things, HF, VHF, whatever, and other antennas are often built on top of the concepts of a half-wave dipole, so it's a good place to start. In this picture, we have it shown vertically, so we have the half-wave being vertically polarized, and so we have really 2 elements, a quarter wave on top, quarter wave on bottom, and then we feed it in the center. Another antenna you probably learned about was the quarter wave antenna. And so we can take the same quarter wave element, again, position it vertically. Instead of having a second quarter wave, we have this big ground plane underneath it, and it had a conductive ground plane. And that reflects the RF signal and creates an image of the actual quarter wave, creates another one down below by reflecting off of that ground plane. And in the end, the performance of this thing ends up being the same as our half-wave dipole. But we do have to have this ground plane. Now you might think of that as a big piece of sheet metal, conductive sheet metal. That certainly could be it. Sometimes we use wire screen. Sometimes we might use wires. We call those radials. We just kind of set a whole bunch of radials out out as a kind of a simulation of a ground plane or approximation of a ground plane. So all those things are true. So this is important to understand so that as we look at some of these antennas, so remember the half wave doesn't need a ground plane, normally fed in the center, but there's a way to feed it on the end as well. And then the quarter wave is half as long, of course, but does require a ground plane. Okay, let's talk about rubber duck antennas that came with your handheld radio. And I like to call these the world's most convenient crappy antenna because actually they don't work that well. But they work good enough. And all antennas are a compromise. And I don't want to be too negative on the rubber duck because it's a pretty handy antenna to use. Put it on top of an HT, put it on your belt, put it in your pocket, whatever. Very convenient. So we use them a lot. It is a shortened vertical radiator. It's not a quarter wave. It's trying to be a quarter wave. It wants to be a quarter wave when it grows up, but it's not quite there yet. A quarter wave for 2 meters is about 19 inches. So these rubber ducks are going to come up a little short. And there's no ground plane. Well, maybe there's a ground plane. Is that HT case a ground plane? Not really. Maybe your hand holding the radio, maybe it's kind of acting a little bit like a ground plane. Maybe your body is a little bit. And we're not too worried about safety here. It's only 5 watts, but really there's no ground plane. Rubber ducks do vary in design and performance. I've measured quite a few of these, and they'll vary in how good of a signal they put out. Typically, I say think of them as about 8 dB worse than a dipole. Some are better than others. So what's inside this thing? So I cut open a couple of them. This one is off of a Baofeng UV5R, and you see you've got this spring in there. It's kind of like a coiled up wire that, again, it's a shortened antenna, so it's trying to, that coil is trying to act electrically longer than it really is. So pretty basic design. Here's one from a Yaesu FT1, and a little bit different physical design. You don't see the coil structure quite as much. You do see there's an inductor down at the bottom that's doing something to make this thing electrically longer. So that's your typical rubber duck antenna. Okay, so it's too short and it doesn't have a ground plane. So what can we do about that? So the first thing you often see is the longer duck, and it's really, kind of the same idea, but closer to the quarter wave. And I'm going to be talking mostly about 2 meters, and make a few comments about 70 centimeters. So these things are typically 19 inches long, which will give it, will make it a quarter wave on 2. So that's good. And usually they work on 70 centimeter as well. But they haven't really done anything to fix the lack of a ground plane. You can buy these things on Amazon or ham radio outlet. There's a whole bunch of places that have these kind of antennas. I do use these. They actually work a little better than a rubber duck. I actually don't think they're that great, but I do use them. Okay, so what can we do about that ground plane thing? Well, you can add a counterpoise. Sometimes we call this a tiger tail or a rat tail, and you take a wire and you attach it to the HT chassis or ground, or think of it as the shell of that antenna connector, and you let this wire hang down. So imagine if you pick up this radio, the wire would sort of naturally orient vertically there and kind of hang down the side of your radio. And so what that's going to do is it's going to give you something that's a quarter wave hanging down. So you can think of that as it completes this antenna. So the rubber duck's trying to be a quarter wave. Okay, it's shortened. A quarter wave sticking up, and then this thing is a quarter wave sticking down, and you kind of have a dipole working there. Or you can think of it as it's a quarter wave vertical with a really poor ground plane, or we'll just call it a counterpoise, something that's trying to take the place of that ground plane. These things actually work quite well. I don't use them very much, but I know a lot of people that are advocates of these because you can still use your rubber duck, and it's kind of a simple way to improve the whole thing. It's just adding 19 inches of wire. Go out on the web and look for different ways of attaching these counterpoise wires. Okay, so let's keep going. The one I like is actually the halfway vertical antenna. And this one in particular is from MFJ. It comes with a variety of connectors on it. You need to order the one that matches your radio. And, think of this as our halfway dipole, except we are going to feed it from the end because it's going to be a lot more convenient if we do that. So inside the end of this antenna, there's a little matching network that allows the HT to drive the antenna from the end. So here's the antenna extended, and then over here we see it collapse down. So it's pretty handy. Now I think the biggest negative on this antenna is it is kind of long. So you're not going to carry it around with that antenna at full length. In fact, it's pretty easy to break these things off. I've broken a few of them. And then you also have to be careful not to put too much stress on the antenna connector because you got this long lever arm that could do some damage to your HT. So it is a handle with care kind of antenna. I will say they work really, really well. They're like way better than a rubber duck. And so if I'm out doing a soda activation or hiking or whatever, and I'm not quite making the contact with the rubber duck, this is the antenna I'll grab and I'll stick it on there, and usually it'll make up enough of a signal difference to complete the contact. So I really like it. Now this is 2 meters only, and I did discover there's a dual band version available. This is on Amazon. Search for the RH770. This also comes in a variety of connectors, and it's $17 delivered to your door. So it's a pretty good deal. I was a little skeptical when I first came across this, but I've used it and compared it to my other half wave antennas for 2 meters, and it works really well. So I'm pretty happy with it. It's got this lump in the middle. We'll call it the magic lump that does add some circuitry in there to allow it to also work on 70 centimeters. So it's a half wave on 2 meters, and it's got some functionality on 70 centimeters as well. So that's pretty handy for these dual band radios. Another popular antenna is the roll-up J-pole antenna. These things are made out of either 300 ohm twin lead, or sometimes they're made out of ladder line, which is a little broader, a little bit bigger profile. And as you see here, they kind of roll up into a coil. You can stick them in a backpack and carry them anywhere, and then hang them up for operation. They're about 54 inches long. You can hang it in a tree with just a piece of rope. You can stick them inside a plastic pipe. You can hang them from a fishing pole, or if you're at home, you might just hang it in a window. It can be kind of a temporary base station kind of antenna that you use with your HT or other radio. It is a half wave radiator, so it's going to work about the same as a dipole, and then it has a quarter wave matching section in there. And let's just take a look at that. Here's a picture of how you could construct one out of 300 ohm TV twin lead, and you make a couple of cuts in it and hook your coax up, not quite at the bottom, an inch or so up from the bottom. And that could be a construction project for you. Just go out on the web and look for roll-up J-pole 2 meters, and you'll find all kinds of information out there. It's also possible to have a dual band version. They add a little bit extra tuning in there, or a little bit different configuration to make it work on 70 centimeters. There are a whole bunch of vendors on eBay that you can buy this from, or like I said, you can go ahead and build it yourself if you want. It's a good project. Another antenna to consider is the mag mount antenna. If we think about an HT, as you drive around in a car, you're inside a shielded cage. You're inside this a Faraday shield, and so the HT tends to not radiate real well through that metal. It sort of works, right? It goes out through the windows or whatever, but it really helps to get an external antenna outside of the vehicle. So a simple one to do that is shown over here on the right. This is a Tram 1185. You can buy that on Amazon, and it's 19 inches long. So it's a quarter wave on 2 meters, and then it has the magic lump there, which is here you can see it's just a coil, and that helps it operate on 70 centimeters as well. But it's about 19 inches high. But it does require a ground plane. Well, no problem. This magnet in the bottom will latch on to the roof of your car, assuming it's made out of steel, and you'll have a really nice ground plane, and they work surprisingly well. The coax then can run through your window, or I think most people just run it through the crack and rubber molding around your door, and you just slam the door shut on it, and it doesn't damage the cable very much. You can get away with that. And so that's how you install those. Now, the big complaint you hear about these is that over time you tend to scratch the surface of your car as you take it on and off, and maybe you plop it on the top of your car and it moves around. It can scratch the finish. Personally, I don't see that as that big of an issue, especially if you're using it temporarily. Okay. The other thing about a mag mount antenna is you can use it a lot of places. So here's a picture of a mag mount. This is a little bit bigger mag mount. It's probably half wave or 5/8 wave, I'm not sure. Plopped down on a piece of sheet metal and up in somebody's attic, KC2SP's attic. And so I thought that was pretty clever use of a mag mount, a way to install it kind of as a base station antenna, and then run it down to whatever radio you have. But it also triggers the other thought of these mag mounts can be used a lot of places. You'll see people just plop them on top of a filing cabinet, maybe on top of a refrigerator, really any hunk of metal. It helps if it's a nice big flat ground plane, but really if you can latch onto any metal, it'll probably kind of work. And I've used them for that in a lot of strange and wonderful locations. People often ask, how big does my ground plane need to be? This actually looks like a pretty good example. I think the answer is you'd like it to be at least a quarter wave from the vertical element to the edge of the ground plane. So that'd be 19 inches for 2 meters, and so twice that for the whole square. But like all antennas are a compromise. If you can't have it be that big, then just use what you can and see if it works. Okay, next kind of antenna I want to talk about is the 3-element yagi, or really the yagis in general. 3 elements turns out to be a nice size for portable operation. So here you see me holding the Arrow antenna 3-element yagi. It's got a BNC connector on it, and you can see the cable coming off, and it's going down to the radio in my fanny pack there. And Joyce, K0JJW, is actually making radio contacts right now. I'm just being the antenna mast. We use this antenna a lot for summits on the air. It's been measured by people on antenna ranges that it's about 6 dB better than a dipole. So it does make a big difference. Here's the kind of the diagram of it. It's got 3 elements. The middle element's the driven element. You see a little matching gizmo there with a BNC connector, and that's basically just a half-wave dipole. And then the reflector element is behind it. It's slightly longer, and the element in front is called the director, and it's a little bit shorter. That's a good example of a basic yagi antenna. It's intended for handheld use, but you could also rig a mast to it, or hold it up with a mast. The reason it's called the Arrow Antenna Company is these antennas are made out of arrow shafts, as in bow and arrow. So they're mechanically very nice, and they're threaded here in the center, so you can unthread this and dismantle the antenna pretty quickly. That's why we like it for portable operation. Works great. Okay, let's talk about connectors. Used to be all the handheld radios had BNC connectors on them, and you see a picture of that here. This cable has a male BNC, and then the radio has a female BNC, and that you'll still see that around on used equipment, but it's been largely displaced by the SMA, which stands for subminiature type A connector. So here's a radio with a female SMA, so you'd need a male connector to connect up to that. But some radios have the male connector on the radio, and so you need a female connection to mate with that. And you really have to check the radio. We have both in the marketplace right now, so make sure you check that out. Here's an SMA connector, SMA male connector on a cable, so that's going to attach to a radio connector like this, the female. So I have this connector or this cable set up. It can work with my Yaesu FT60, the FT1. Lots of radios are compatible with that. But make sure you get the right connector and the right gender of that connector. Typically for HTs, we're not going to be using PL259s, which is the larger connector. It's just too big. So you want to avoid that. Although if you had a cable or you wanted to buy a cable for other reasons that has PL259s on it, you can always come up with an adapter that adapts it back to BNC or SMA. And so we'll take a look at those. Okay, a little bit about cables. There are 3 common sizes of cables in ham radio. There's the smallest, or the smaller one here is RG58. It's about 0.2 of an inch in diameter, and this is what we use for mobile installations. It's pretty good to route around inside a car. RG8X is a little bit bigger. It's about a quarter of an inch in diameter, and it gives you a little bit lower loss than the RG58. And if I can, if the slightly bigger size is not a problem, I tend to get the RG8X when I can. And then the bigger cable is RG8U, or there's a bunch of variations on that, but they're all that 0.4 inches in diameter. So this is a pretty big cable. It's probably not what you're going to be using with an HT. If you have a really long coax run, you might want to use the larger cable. Larger cables generally have lower loss, and so keep that in mind. And really, most of the stuff we do with an HT, the cables are pretty short, so we're not going to be very concerned about loss anyway. Now, if the cable gets up to about 20 or 25 feet, then you probably want to go and calculate how much loss you're getting and make a decision about that. These things are all 50 ohms, or we want them to all be 50 ohms. We want to use 50 ohm cable because that's what our HT likes, and that's what our antennas like as well. That'll give us a good match. But make sure you get 50 ohms. If you go out to Amazon, you'll see some 70 ohm cable in there. You don't want to buy that. And I think for most of the things we're talking about, you just want to buy pre-made cables with the right connectors on them, and not have to worry about attaching connectors. Or maybe use some adapters, right? If you need to adapt it, but you probably don't want to get into the business of attaching cables or attaching connectors if you can avoid it. Okay, and then there are some smaller ones. There's another cable called RG316. It's about 1/10 of an inch with diameter. You can use those as well. But again, make sure whatever you get is 50 ohms. Here's a typical cable you could buy off of Amazon, or you could get it from HRO, Ham Radio Outlet, or DX Engineering, any of those guys. I almost hesitate to recommend Amazon for buying cables, but I do buy some cables from them, mostly because Amazon has so many different suppliers out there, and they vary in quality. So I think you really want to look at the reviews from people and try and verify that it's a high quality supplier, because there is some junk out there. HRO, DX Engineering, those guys are going to have more reliable vendors, but they'll tend to be maybe a little more expensive than Amazon. And my rule on cables and connectors, if I ever encounter like a poor quality cable or a connector or an adapter that's giving me trouble, like it's a little bit intermittent or I can tell it's not a good connection, it goes in the trash. Life is too short to deal with flaky cables and connectors. So that's my view of the world. Okay, here's some adapters. So you may not have the right connection on the end of a cable. And like, I showed with that arrow antenna, it comes with a BNC on it, right? So right away, I'm going to need a cable that can handle the BNC end of that. And then on the HT connection, that's going to be SMA. So somewhere in there, I'm either going to build a special cable or buy a special cable, or I'm going to have an adapter or whatever. There's tons of adapters out there. So like in the upper left, you see these are SMA to BNC adapters of various genders, right? So you have to look at the gender carefully. Down here is the PL259 style to BNC. So you can adapt those, again, multiple genders. The one here in the center, upper center is SMAs, but they're the same connector on both ends. So these might be useful for connecting two cables together, right? Down here, some more SMA and BNC. In the upper right, we've got SMA going to PL259, so you can adapt that. And then lower right is actually just a short cable. You may not want an adapter. You may be better off with just a short cable with the right connectors on both ends, because this cable will provide some flexibility. Kind of depends where you're installing it. You can buy this stuff on Amazon, DX Engineering, HRO, lots of places. I'd say just be very careful looking at the type of connector and the gender to make sure you get what you really want, because it can be confusing. If you just read the description and it says SMA, you may want the male and get the female instead, or whatever. Just be very diligent about checking that out as you order. Okay, so that's kind of our run through of antenna options for your HT. Again, your rubber duck antenna, convenient and crappy. It's a good antenna to use when you want something short and you can't tolerate a longer antenna. Antennas are a great way to improve your signal, so definitely think about these options and try something out. Pay attention to cables and connectors. You got to get things connected up right, and you may require you to buy an adapter or two. Most of us end up with a little kit of adapters because we're using different cables and connectors and antennas configured in different ways, and so you end up with some adapters to help you keep that keep it flexible, versatile. And then I'd say try some things. These things are not super expensive, so they're a good way to experiment and see what works for you in your particular situation. So that's it. Thanks for listening, and have a great day.